Welcome to our Harbor WildWatch lesson today. This is probably the coolest experiment we will have done this far, and that's because today we get to learn about glaciers. So we'll be investigating these huge chunks of ice and how they've helped to shape the landscape that we enjoy today. So if you're tuning in, I would love it if you could write in the comment section where you're tuning in from and what grade the students who are tuning in with you are. That helps with our great reporting. So let us know where you're tuning in from, who's tuning in with you, and what grade they're in. So with that, while we do a little bit of an overview of fabulous, wonderful glaciers, the materials that we'll need for today's experiment include some modeling clay. I recommend not Play-Doh. You want something that's not water soluble because we're going to be using some ice to rub across that clay. So if it's water soluble, it's going to get a little messier. I actually haven't tried it with Play-Doh, so have at it and let us know how it goes. But kind of this like never dry type clay works pretty well. And then you'll also need some sand or gravel. This is just literally sand from a playground. So a bit of that, and then a surface that you can get a little bit messy because we know that science tends to get messy. This experiment is safe though, so no eye protection required. So with those materials, you'll be ready to go when we get to the experiment part of today's lesson. So what is a glacier? We're gonna find out. All right, there are 4 key features that I want you to know about glaciers. The first you might expect, actually in the comments, maybe you can guess. What are some things that you already know about glaciers, or things that you wonder about glaciers? They are definitely made of ice. That's probably the first thing that comes to mind. This ice is formed by the snow that falls in cold places. So whether you're on the north or south pole of the globe or in a high elevation area like the top of Mount Rainier, that snow will fall, and those layers of snow, the top layers are gonna pack down the bottom layers. So I like to kind of think of it, if you've ever, on those nice few and far between but snowy days here in Washington, if you're having a snowball fight, and if you've ever picked up some snow and packed it together so tightly that you actually end up forming an ice ball, that's kind of how glaciers work. Of course, if you're throwing ice balls, that's not very nice. You want those nice fluffy snowballs. So don't be like a glacier when you're having snowball fights. Be fluffy and nice. So but that glacial ice forms because lots of layers of snow are gonna pack down the bottom layers of snow and really like squish out all the air, forming a dense chunk of ice. So glacial ice is more dense than the ice you'd find in your freezer because it has been compacted by so much snow. So ice is definitely a key feature of glaciers. Another thing about glaciers is they are huge. In the comments, feel free to throw out another synonym for the word huge, whether it's big, enormous, massive. This is a good check-in on that, so if you want to have some interaction, yeah, what's another word for huge? Because glaciers, they are large. And to think about how big they are, I want you to imagine that it's bigger than your house, it's bigger than your county. Glaciers can actually be bigger than all of Washington state. So these are massive chunks of ice. If I think about Antarctica, there's a series of glaciers that pretty much take up 98% of that continent. So that is, I don't know, I'm trying to see if get some comments in there. Maybe I'll turn those on. There we go. So yeah, very, very large piece of ice. Another feature I want you to know, in addition to that glaciers are large chunks of ice, they are also heavy. And that is because they're huge. If I think of how much a gallon of water weighs, it's a little over 8 pounds. And kind of similar to a milk jug, but if we think back to our density lesson when we talked about solving the estuary mystery, milk of course is a little more dense than water, so it's going to be heavier. But generally, you know, imagine that 8-pound gallon of milk that you're walking in from the store, and then like extrapolate that. Imagine you fill an entire room full of those milk jugs, freeze them, and like imagine trying to pick that up. We need to get creative with our engineering here and maybe like, I don't know, develop like a lever, a pulley, some sort of thing. I don't think we could get our fingers underneath and lift it on our own. So just a room full of ice would be heavy, but again, imagine a Washington state sized chunk of ice. Very, very heavy. And these 3 features play into our last feature, which you might be surprised to know that glaciers move. Do you want to see how fast they move? Are you ready? Okay, they're really slow. If you want to improve your writing, say you're writing an essay and you want to describe the speed of the snail, you could say the snail moved at a glacial speed. And I would read that sentence and I would know that, wow, that is one slow snail. So glaciers, they don't move very fast, but the gravity of that layering ice going to slowly push them down. So think of it like a frozen river slowly sliding down the face of a mountain, and you'll have kind of a glacier in mind. So with that, we have these 4 features that are going to help us out with the experiment we're about to do. We're going to demonstrate how this big heavy chunk of moving ice can essentially act like nature's bulldozer and change the landscapes that we know today. So, ooh, like a sloth. Yes, that is a perfect description. Although I might say a sloth is probably a little bit faster than a glacier. Thanks for that shout out. Okay, so to move on to our glacially slow sloth. Okay, you're hilarious out there. We're gonna move on to our experiment. So I'm gonna need you to take just a nice little chunk of clay. I broke off a piece. You're going to roll that clay into a ball. Doesn't have to be perfect because you're gonna then squish it with your fingers. I recommend using your fingers to make kind of a nice chunky pancake's worth of clay. I don't really want you to like smash it onto whatever surface you're using, because you can be really good at that and kind of flatten it too much and press it to your table. So I want a nice thick chunky pancake type thing. I'm gonna flip our screen so you can see down here. Okay, so once you have your nice chunky pancake, go ahead and lay that on your surface. And I now want you to imagine, ooh, this little chunk of clay is Washington State. Over 10,000 years ago, before the last ice age. Now, obviously, Washington State is not a round little chunk of blue clay. So again, when we're talking about models, they're gonna mimic reality, but they're never perfect. So to make this model a little bit better, that sand that I mentioned, we're gonna take a pinch of that, because that Washington landscape, of course, has rocks and dirt. So we're gonna make it a little bit more realistic with our sand here. Now, of course, we're missing things like the forests and all sorts of other things, but for the sake of a simplistic model, we're just gonna go with clay and sand today. I also have a towel on hand in case things get messy, so you might wanna grab that. All right, so our little Washington State here, before the last ice age, looks pretty cute. Ooh, I love it. I want you to make some observations about your Washington State, and I really want you to kind of get the image of this current Washington State in your mind, because things are about to change. We're gonna bring on the last ice age. And to do that, we're gonna think about our features of our glacier, right? They're made of ice, they're huge, so if I grab this nice ice cube here, it is cold. I don't think my fingers will freeze off though. So it's made out of ice. Compared to my Washington State, it's definitely quite massive. And here's where I'm gonna need you to really bring this glacier to life. When we scrape this glacier across our Washington State, I'm gonna need you to press into your Washington State because we need to make sure that we're demonstrating how heavy this ice can be. And so when I move this across Washington, I'm gonna press and scooch because it also has to move. Now, we are definitely gonna speed things up a little bit because if we were moving at a glacial speed, I'm gonna put a link to a video in the comments of a glacier that moves 2 feet in one day, which is about an inch an hour. That, my friends, is slow, and as much as I know you love tuning into Harbor WildWatch videos, I don't think you want to be here all day watching me glacially do this experiment. So we're going to speed things up, we're going to press, we're going to scooch, and then we're going to make some observations about how this glacier changes our Washington State. So, wow, it's kind of, oh my gosh, a little slippery here. So if you're ready out there, feel free. I'm gonna make a prediction, of course, because I'm a good scientist, that this glacier is gonna change our shape of Washington State. How exactly? Let's find out. So I'm pressing, I'm scooching, I'm pressing, I'm scooching. Oh, uh-oh, that's okay. We're gonna keep going. Drastic changes are occurring. I don't know how long we want to do this. Yeah, okay. I think my table's gonna scooch more than my ice. Okay, that's, I think, looking pretty good, friends. I'm gonna set our ice cube off to the side. I'm gonna use some friction to warm up my cold fingers. And then let's talk about what we noticed. All right, so I'd say that we pretty effectively obliterated our Washington State here. Glaciers are one of the many things that cause erosion, and that word means when dirt moves. There's things like water erosion that also is probably taking place, so water can move dirt, wind can move dirt, and these glaciers can move dirt, although very slowly. So I'm looking at our Washington, and it doesn't look anything like the Washington that we started out with. All right, the rocks have moved. There's some different cuts into my Washington State. It's even been completely separated in some cases. I like in other instances I've seen where there's like a hole carved in. And so I'm looking at this and I'm noticing that I can probably draw some pretty cool parallels to what actually happens when you have a real glacier doing real erosion on your landscape. And so I'm gonna see if I can pull up a picture because I want to make it clear. Let's try this. Yeah. All right. The Puget Sound was indeed formed by glaciers. So I'm looking at our Washington State here, and I can see all these cuts. Like maybe we formed our own version of the Puget Sound in this model here. Back in the day, over 10,000 years ago, Washington State was covered in ice. And if you want a nice visual, I love this image because it shows kind of how, if you imagine the Space Needle and then stacks 5 Space Needles on top of each other, that is a prediction for how much ice was on top of our landscape over 10,000 years ago during that last ice age. And so that movement of this sheet of ice across our state helped to form the Puget Sound. And so here's kind of where that ice was located. So here's a little picture of Washington down here, and this big ice sheet that stretched across to the Rocky Mountains. As it moved and shifted, that erosion carved out all these intricate parts of the Puget Sound. Now, in addition to the ice moving, there was also some water erosion. So as the ice moved and melted away, different things flooded. And so there's kind of a handful of different erosion types that helped to make Washington what it is today. But really thinking about the ice as the main driver of this huge, beautiful marine habitat that we have. And then being connected to the Pacific Ocean lets the salt water mix with the over 10,000 rivers and streams that are flowing into this area, which makes for the second largest estuary in the United States. So the Puget Sound is very cool. You've probably seen Rachel and I doing some beach walks. We look forward to doing a lot more of those with some upcoming low tides, but we get to do that because of the glacial past of this place. So I don't want to be too Washington-centric, so I want to include that the Puget Sound is also part of the Salish Sea, which is an area that includes the Strait of Juan de Fuca, as well as the Strait of Georgia up in Canada. And all of these three bodies of water together get called the Salish Sea, which is a very cool habitat. And you can see just that evidence of, okay, there was definitely a glacier that moved across this landscape to leave, to form this amazing place. And if we want to get even further out, we can also think about the Great Lakes. These are also bodies of water that were formed by glaciers, but because they're not connected to the salt water of the ocean and they're just fresh water, they get to be lakes instead of estuaries. So kind of cool connection there. Okay, so if I wanted to kind of go out and about, and obviously we're no longer covered in ice, but there's absolutely evidence of glaciers throughout anywhere where there's been ice ages previously. So big rocks like this are called Glacial Erratics, and they are essentially left behind by the chunks of ice. So I'm gonna look at our glacial erratics that have been moved around here. In Washington State, we can kind of connect some of the erratics that we see here. Those rocks can be matched to the rocks that are up in Canada. So when that ice melts, kind of like a snowman, it's gonna leave behind the carrot nose and the hat and the buttons and the scarves, because that ice is just gonna, whatever was held in the ice is just gonna drop. And so as that ice moves, it picks up the dirt and the rocks. Sometimes those rocks can be bigger than houses, and it's gonna scrape those along our landscape, which really kind of goes back to why we might see things like the Puget Sound or lakes. And so when that ice retreats, it's not like it gets pulled away, it just melts and leaves whatever's in the ice behind. Another evidence of glaciers is the U-shaped valleys that glacier leaves behind. The erosion from a river forms a V-shaped valley, as you can see over here. And then for glaciers, because as we've talked about, they're huge, they're heavy, and that ice moving is really just gonna scoop out these big, more U-shaped valleys, because that erosion power from a glacier is less concentrated, it's more dispersed than a river's erosion would be. And then another kind of cool feature, in the Columbia Valley in Washington, we see a lot of these Kettle Lakes. So sometimes as that glacier's moving across your landscape, chunks of ice will get knocked off and buried. And so as those chunks of ice melt, they leave behind a hole. And so kind of, I don't know, these are just gorgeous pictures of a landscape that just has all these little pockmarks left behind by those glaciers. So you can always look for those as evidence that there's been an ice age in your area. And then of course, all glaciers haven't gone completely away. In Washington, there's still the cold, high elevation areas where there's lots of glaciers to be seen. Mount Rainier is a great example of that. And yeah, so if you want to get out, get those hiking boots on and go visit a glacier before they're gone, because unfortunately many of the glaciers in our world are melting away rather than advancing, and that's definitely concerning when it comes to the different species that depend on that ice as part of their life history. And yeah, so climate change is not being very nice to our world's glaciers. So with that, pop that over. I hope that you will absolutely share, what did your ice age do to your Washington state? You're welcome to have a second ice age and keep going at it. It's kind of fun to see how that glacial erosion can really transform a landscape and form things like the Puget Sound. And so with that, I hope you had fun with today's experiment. Again, if you're just tuning in, if you could let us know where you're tuning in from and what students are tuning in with you, that would be absolutely fabulous. If you enjoyed this video today, we'd love for you to share it with your friends, like us and follow us on Facebook, and what's the other social media? Instagram, that one. We love those followers who post all sorts of content there. If you're not on social media, you're welcome to subscribe to our YouTube page, where you'll get updates to our new content that we post there. This video will be one of those things that our lovely Carly, who's out there running tech for me right now, she'll be posting this on YouTube later. So subscribe to that channel so you're staying up to speed. And then also please consider joining our Steward Club. Not only will you receive our exclusive content as a member, but you'll help our team continue to provide these virtual learning opportunities. So with that, thank you all so much for watching and tuning in. And don't forget the Harbor WildWatch motto of learn, have fun. Have a great day.